All right, everybody, we're going to be talking about covalent bonding in this video. Covalent bonding is going to be between non-metals with other non-metals, as opposed to ionic bonding, which was between metals and non-metals. Metalloids can be involved in both at times, but we're going to focus on the non-metals and other non-metals with this video. So we have three different types of bonds we're going to discuss with this. So by the end of this video, the hope is that you will understand how the three different type of bonds work, and then what the difference is between a Lewis structure and a structural formula. So we have a single bond, a double bond, and a triple covalent bond. There's no such thing as a quadruple or anything like that, but here's an example of all of them. So first of all, let's talk about hydrogen. Hydrogen has one valence electron. If it is sitting next to another hydrogen with one valence electron, they would each have two valence electrons if they're sharing each of theirs. That gives them both what they need or what they would want to become stable. That's the goal here. They look like a noble gas now. They both have two, like helium would. The same would be true if you did like HCl. H has one, Cl would have seven, and that those seven could be placed like this. Now chlorine has 8, makes it look like a noble gas. This hydrogen has 2, makes it look like a noble gas. Lewis structure would look like this. If you show the electrons for dots, actually be just like the one I just showed you. For the bonds, I should say, the dots for bonds. The dashes, you could use a dash for the bond. That indicates there's 2 electrons being shared right there. But Lewis structures must have the lone pairs shown every time. And these are lone pairs that are not bonding. Structural formula doesn't show those lone pairs. All it shows is the bonding that's involved in them. In the case of oxygen, we can make a double bond with oxygen with itself. Double bond, if we think about oxygen, there's 6 valence electrons in each oxygen, sitting next to another oxygen. Essentially, these can get shared, these can get shared, and it ends up at, hey, this oxygen, that kind of looks like a weird clown at this point, and then we can make it look like a weird pretzel. If we think about these are the 8 around this oxygen, and these are the 8 around that oxygen. But there's a better way to clean that up to show the Lewis structure. We would show 4 between them for a double bond, and then each of them have 2 more pairs of electrons. Whenever you do a Lewis structure, they need to be in pairs. So that would be with dots as the bonds. Here we could show dashes as bonds, which is when there's 2 dashes, that's indicating a double bond. And then here's the structural formula for that same thing. Again, lone pair is not shown for a structural formula versus Lewis structures, they need to be shown. But both of these are accurate Lewis structures as long as you're showing those lone pairs that are not bonding as well as the bonding pairs. An example of a triple bond would be nitrogen. Nitrogen has 5 valence electrons. And let's put it next to another nitrogen that has 5 valence electrons. These could be shared, these shared, and these shared. I'm not going to draw all the craziness, but it ends up that they both are able to have 8 by sharing 6 of them. And it ends up with a triple bond being the most stable situation for the nitrogen, which is the majority of the molecules around your face right now that you are breathing in. Obviously, maybe not obviously, but the majority of the rest of it are these oxygen molecules. So that's what the nitrogen molecules would look like. Soon in class, we're going to have you determining if we're going to have single, double, or triple bonds in formulas. And there's a set of rules that's not too bad to be able to figure those things out. But that's where we're headed with these bonding soon. I just wanted you to see the difference between a Lewis structure and structural formula and how single, double, and triple bonds would be shown with each of those. And that's it.